Hey guys, I hope you guys are doing well. I'm going to do a little video on how to do section 4.2, which is how to solve multi-step linear equations. So similar to 4.1, you're going to follow the steps for SAMDEB. Okay, so SAMDEB again is just BEDMAS backwards. And when you follow BEDMAS backwards, that stands for subtraction, addition, multiplication, division, exponents, brackets. Okay, so using SAMDEB, you actually can help solve and isolate for your unknown variable, and that's something that you worked on in 4.1. In 4.2, you'll also sometimes be doing distributive property, so I'll also do an example where we have to deal with distributive property and how to apply it, and then we'll also be dealing with ones like fractions. Okay, so the first example I like to do with you guys is 3a, which is on page 169 to 170. And for 3a, I want you to pay attention to this wall that I drew. So on that wall, you'll notice there's a red wall that's just right here, and I want you to think of that every time you take a term and it crosses over that wall, it's going to change its operative sign. So for instance, when we have our 2w, if I was to move that term to the opposite side, that positive 2w now actually becomes a minus 2w. For now, I'm going to leave the negative 2 still on the left side, and what's left then on the right side would be a positive 3. I'm going to simplify 3w minus 2w, which actually becomes w. I have minus 2 still on the left side, set equal to 3. So similar to that example where I moved a term over the wall, I'm now going to collect like terms with negative 2 and positive 3. To do that, I'm actually going to move my negative 2, and I'm going to move it over to the right side. When I move that term over to the right side, I now am just left with w. That's going to be set equal to 3, which stayed, plus 2. And together, when we add 3 plus 2, we actually just get 5. Okay? So those just show how in this lesson you can notice that there will be terms on both left side and right side of the equal sign, and you're able to move them around to isolate for your unknown variable. Just keep in mind every time you cross that wall, you should change its operative sign. So again, every time you have a subtraction sign like we did with a negative 2, once you bring it over, it now becomes a positive 2. I'm just going to bring this down slightly, and I will work on a question that involves distributive property. Okay, so for distributive property, we could take a look at a question like 4a. So for 4a, we have 3, open bracket, x plus 6 is equal to 2, open bracket, x minus 1. So the first thing I should do is I should take each term that's outside the brackets, and I'm going to distribute it by multiplying inside. So what I should have on the left side is 3 times x added to 3 times 6. So I should get in this step 3x plus 18. And on the right side, I should be getting 2 times x, which is 2x, and then 2 times negative 1 becomes negative 2. At this point, we're going to actually borrow the steps of what we did above, where we move terms over that equal sign, over that wall. So quite similar to what we did in the last step, I'm going to bring 2x, and I'm going to cross it over to the other side. So what I would have in that step is I would have 3x minus 2x plus 18 is equal to negative 2. So notice I did collect like terms when I crossed over that 2x, and I just put it right beside 3x, but I didn't change any of the signs for the other terms. So positive 3x still remains, positive 18 still remains. The only thing that has changed is that 2x on the right side is now a minus 2x. So once I collect those like terms, 3x minus 2x is just x. I'm then going to take that plus 18 that's on the left side, and I'm going to bring it to the right side. So we know the opposite of adding 18 is subtracting 18. So my final answer should be x is equal to negative 20. Okay. Now the last step I'll go over with you guys will actually be one that deals with a fraction. So I'm just going to reset stuff on the left side. So this is actually 5a on page 170. And how the question starts is we have 4a minus 1 divided by 3 is equal to 5. Okay, so your original equation is actually just what I'm highlighting now. And you can take a look on page 170 if you want to see it for yourself. Okay, so that's the question as it starts, which is 4a minus 1 over 3 equals 5. You want to isolate for a and figure out what a is equal to. Now, the thing that gets in the way is dealing with that division sign. Okay, so you'll notice that you have a division sign, which is where that red line is highlighted, and you have it over 3. To eliminate 3, what I'm going to do is I'm going to actually multiply both sides by 3. Because once I multiply both sides by 3, the 3's on the left side cancel, because 3 over 3 is just 4a minus 1, because the 3 over 3 cancels and it goes away. And then I'm left with 15 on the right side, because 5 times 3 is 15. At that point, it just becomes a two-step problem. We have 4a minus 1 equals 15. So what I'm going to do is I'm going to collect like terms where I take that negative 1, I'm going to bring it to the right side, so that negative 1 becomes a plus 1, and I'm just going to add 15 plus 1. Now we know 15 plus 1 is equal to 16, and on the left side, I'm still left with 4a. Okay, so at this point, we need to think, what is a number that multiplies to 4 and equals 16? So to undo multiplication, we're actually going to divide. That is how we undo our operations. So I'm going to divide both sides by 4. Notice how the 4 over 4 cancels. I'm now just left with a, and 16 divided by 4 is just equal to 4. So my final answer for this one is going to be a is equal to 4. Okay? So hopefully that is clear for your expectations for 4.1 and 4.2. Okay, I'd like you to do the questions at home to help supplement your learning, and at any time if you get stuck on any of the questions, please don't be afraid or don't hesitate to ask me. Just send me a message on Netsby and I can straighten it out and hopefully help you out online. Okay, have a good day.